I was not going to record today, but this question was just too brilliant. I realized that I need to address it. So the question is, okay, Mars and Pluto both formed around the same time, right? And in previous videos, I talked about how Mars has cooled to the point in its interior where we don't see a lot of volcanic activity happening anymore. Well, Pluto is a much smaller body. It's farther away from the sun, but we're still seeing volcanic activity on Pluto, right? So how could that be? Well, here's the thing, and I actually brought some props. This is a Lego, but let's pretend that this is an ice cube, right? And I just picked up a rock, okay? So we've got an ice cube and a rock. These are both frozen. They are in the solid state. Now, if I wanted to melt them, think about how much energy I would have to add to this rock versus my ice cube. Or actually being plastic, I probably would not, I could melt this in the oven, right? But there's no way I'm going to melt this rock in the oven. I'm going to have to bring this up to, 1,000 degrees at least to be able to start to get anywhere close to melting this. So that's the trick. If we think about what Mars is made from, well, Mars is like Earth. It's made from rock and metal. Those things have really high melting points. But Pluto, on the other hand, yeah, it's got some rock in there, but it's actually mostly ices. So it's water ice and nitrogen ice, right? When we look at the surface of Pluto and we see that it's got these amazing mountain ranges, things higher than the Rockies even, well, that's made from water ice. So the temperatures necessary to actually melt ice is very, very different than the temperatures needed to melt the kinds of rocks that we have here on Earth. Now, interestingly, getting into the technical terms, ice really is a mineral, and what Pluto has are rocks as well. But I'm talking about the kinds of rocks that we classically think of as being rock, right? Now, other question involved with that is, okay, so where's Pluto's internal heat coming from? And this is an area of active investigation, but there are a few ideas. One, probably some radioactive decay. Two, there's probably some tidal interaction, some friction happening from the tug and pull with Pluto's moons. And then there's simply internal pressure, just from the weight of the planet crushing down. So Pluto is much, much colder, but because of the materials it's made from, it can have volcanism at much lower temperatures. So again, brilliant question there.